Welcome. Let's take a look at an example where we can write a polynomial into a product of linear factors. Well, let's have a strategy for this. To properly write down this polynomial into linear factors, we need all the solutions that this polynomial has. Well, within this polynomial, notice that it is of degree 3. So we should expect to have 3 solutions. So now that we know what the objective is, let's find those solutions. Now here is when you make a decision how we're going to find those solutions. To me, it's always easy to find the solutions when I graph our function. So let's graph this polynomial. And notice that we are able to identify one of those solutions right here. Notice that it is at this location where we are intersecting the x-axis. So out of the 3 solutions, we know one of it. Well, let me call that solution 1. It is when x is equivalent to 2. So we're missing 2. But notice that we're not able to find that second solution in our graph because we're only intersecting the x-axis at one location. Well, if x equals to 2 is a solution, then I think it's fair to say that x minus 2 is a factor. So how about we get the polynomial that we were given and we factor out the expression x minus 2 and let's see what happens there. Let's perform synthetic division. So for synthetic division, notice that our polynomial, it's already in standard form. The degrees goes from 3 to 2 to 1 to the constant. So we're good. What we need to do, let's get all those coefficients and put them down in a list. So we're going to have 1 followed by negative 2, followed by positive 1, followed by negative 2. Now let's write our upside down box and let's perform our synthetic division. Where on the outside, we're going to place the value of our solution, which is equivalent to 2, which is the opposite of our factor. X minus 2, opposite, put down a 2. And now let's perform this division. Bring down the first value, perform multiplication. 1 times 2, that is 2. Let's write down in here. Let's combine it. That's equivalent to 0. We're done. Let's repeat that one more time. 0 times 2, that is equivalent to 0. So let's put it down underneath the next number. Let's combine them. 1 plus 0, that is 1. Let's repeat that one more time. 1 times 2, that is 2. Let's combine them. We get 0. But we were expecting to have 0 as a remainder because we knew that x equals 2 was a solution. So now let's make sense of our result. The given polynomial was of degree 3, so therefore 1, it is going to be the coefficient of 1 degree less, which is x to the second. Then 0 is going to be the coefficient of x, and 1 is just going to be our constant. So now the given polynomial, it can be written in the following way. X minus 2, because we already knew that it was a factor, so we can factor that out. And what is going to be left is the result that we obtained from the synthetic division, 1x squared plus 1. Which I'm just going to write that down as x squared plus 1. But let's keep in mind what we were looking for. We are looking for solutions. We needed 3 solutions. We already have one of them. We are going to obtain the 2 remainder solutions from the expression that was left after we factor the expression x minus 2. So to find the solution from x squared plus 1, let's get the expression of x squared plus 1 and let's set it equal to 0. We can move 1 the left hand side, so we're going to get x squared equals negative 1, and we can take the square root of that, and now we're going to get our 2 solutions. X equals positive square root of negative 1, and x equals negative square root of negative 1. But the square root of negative 1, we can just write that down as I. So therefore, our second solution is negative I. So we are done. Because our second solution, which I'm going to write in here, let me call that solution 2, that is equivalent to I. And our third solution, it is negative I. So now we have all the information that is needed to write our polynomial in factor form. And I just realized that I forgot to write down a because we do not know what's the coefficient of this function. And now we can bring down x minus 2 because this is the factor that we obtained from this first solution. Now, the factor that we're going to obtain from when the solution is I, it is going to be x minus I. And the factor that we're going to obtain from our third solution of negative I is going to be x minus negative I. But a subtraction of a negative, that is just an addition. So let's write this down as positive I, and we are done. The polynomial that we were given of x to the cube minus 2x squared plus x minus 2, it can be written as some coefficient times the combination of the following linear factors: x minus 2, x minus I, and x plus I. They're all multiplied. Hello. If you would like to continue learning about mathematics, you can check out the videos on the left.